Welcome to the summary video, a simple introduction to Python. To keep the workshop simple, we will be using Google Colab, which is cloud computing, which means you do not need to download any software onto your own computer. You do need a Google account, so you will need to register with Google. In the search engine, you simply type Google Colab, and it will be the first hit up here. When Google Colab opens and you are logged in, you can create a new notebook or you can open one of your previous notebooks. So just like Blue Peter, I've already have one prepared. We have either a code cell where you can write Python code or a text cell where you can put English and mathematical equations and figures, etc. So this is a text cell. To insert a title into your notebook, use the hash symbol, and you'll see that Google Colab even shows you what the cell will look like when you execute it. To execute the cell, you simply hit Shift Enter. So the title of our notebook is A Simple Introduction to Python. To insert an image, so this is now a code cell, so we use Python code to insert an image. So we need these lines of code, and you'll see that we're going to insert this simple python.png image. So you simply drag and drop simple python.png into this folder on the left. And these commands, if you hit Shift Enter, then the image is inserted into your notebook, and you can see we can change the width of the image. So all delegates will get a free copy of my book. So you can download this from CRC Press. The aim of the workshop is to learn a high-level general-purpose programming language, and at the end of the workshop, you will be able to use Python as a powerful calculator. You will be able to write simple Python programs. You'll be able to produce colorful figures and even animations. You'll be able to write professional-looking notebooks, which are textbook quality. And finally, you'll be able to incorporate programming into your research. And for final year students, hopefully you will use Python in your final year project dissertation. So here is another code cell here, and now we can see that we're going to insert the itinerary.png. Again, you can see I've dragged and dropped it into this folder, and I again make the width 800. So this is the itinerary for the workshop. On day one, in the first session, you will use Python as a calculator. The reason I introduced this first is because everyone is familiar with how you use a calculator from school. You'll see there are coffee breaks with exercises for you to get hands-on experience with Python. In the afternoon, I will introduce you to simple programming, how to define functions, loops, for loops and while loops, and finally if, elif, else statements. And with those three constructs, you can write any program. On day 2 in the morning, I'll introduce you to the Turtle library, which is a lot like the Scratch programming language, which is very popular with school children. And in the afternoon, numerical Python and matplotlib for producing colorful figures. And we'll give you an example of that in this session. On day 3, we'll look at Google Colab for cloud computing, symbolic Python for mathematics, for differentiation, integration, etc. And also GitHub, where you can share your files and you can even publish your own web pages, like I have done. In the afternoon, I'll show you how you can get a deeper understanding in mathematics by using Python. On day 4, I'll introduce you to cryptography, and in the afternoon, artificial intelligence. I'll explain to you how artificial intelligence works from the very basics. And then finally, on day 5, we'll have an introduction to data science, which is used right across the breadth of probably all of the subjects now at university. And the final session will be an introduction to what we call object-oriented programming. So to insert code into these cells, we just simply hover at the bottom here, and we should get a code or a text. Okay, so we'll do a code cell. We're going to first look at BOD maths, because this is the kind of thing you do at school. So suppose we want to do 20, take away 3, multiply by 5. Notice we use asterisk for multiply, and we leave a gap between the operators, and that's simply to make the Python code look pretty. To insert a comment in Python, we use the hash symbol. So this is going to be BODMAS. So it's brackets, order, division, multiplication, and addition and subtraction. So I'm sure you're all aware that we do the multiplication before we do the subtraction. Shift enter to get the result, or you can hit the little play button and you can see we get the correct answer, 5. Next we look at fractions. So suppose we wanted to add 1/2 plus 1/3. So that, again, this is fractions. Hit shift enter to execute the cell, and you can see we get an answer, but this is not exactly 1/2 plus 1/3. To get what we call a symbolic answer, we have to import a library. So there is a library called fractions, and from that library we're going to import a function called fraction, and notice it's a capital F. So we can execute the cell again, and now we can use this function to add 1/2 and 1/3 symbolically. So the function is called fraction. The first number is the numerator, the second number is the denominator. So we have 2 arguments in the function. Then we add fraction 1/3. So the first number is the numerator, second number is the denominator. If we execute this cell, then you can see we get the exact answer, 5/6. Next we're going to look at powers. So suppose we wanted 2 to the power 9. Okay, in mathematics we call this exponentiation. So this means 2 times 2 times 2, 9 times. And notice we do not leave a gap when we take powers. Next we're going to insert some functions from the math library. So from the math library we are going to import the square root function, which you will all be familiar with, and another function called floor, which I'll explain in a moment. And we'll also introduce the constant pi. We're going to import pi because we're going to use that in a function in a moment. You'll all be familiar with the square root function. Square root. So for example, if we want the square root of, say, 9, then this will give us the positive root. Okay, so the positive root of 9 is 3. Just to give you an indication of how this workshop is hands-on, suppose I introduce you to this new function called floor. So this gives us the largest integer less than or equal to x. So if I asked you what's the floor of 2.3, give you a second to think about that. Yeah, you want the largest integer less than or equal to 2.3. And the answer, of course, is 2. Now, in order to show that you've understood this, the next question, suppose we wanted the floor of minus 2.3. So we want the largest integer less than or equal to minus 2.3. So this might take a bit of thinking about. So some of you will have the correct answer, some will have the incorrect answer. You see the answer is minus 3. Now this is where Python can give you a deeper understanding of mathematics, because you just keep on making up your own examples until you understand how this floor function works. Next I'm going to show you how you define your own function. Okay, so let's define our own function. Okay, so we're going to define our own function. Now, if we hit return without shift, then we stay in the cell. So we're going to define a new function called area circle, underbar circle. And this is going to have the argument of r. R is obviously radius. To end the definition of a function, we use the special character colon. And notice that Python indents for us. Indentation is vitally important in Python. So we want to return, so the area of a circle, I'm sure you're all aware, the area is given by pi times r squared. Pi r squared is the area of a circle. So for example, suppose we want to print out the area of a circle. So we have area circle. So we could make this, so we say area is equal to, and then we want to call our function, which is area circle, and suppose we want to find out the area of a circle of radius 4. And then we're going to print out area equals whatever the area is, and then in centimeters, say squared. Let's say we're working in centimeters. So we can use this print to make the output look pretty. So there you can see we've got the area is 50.265, etc. centimeters squared. So that's how we use the print statement. So there is our first function. Next, finally, I'm now going to show you how to produce a pretty picture. So in order to produce pictures, we're going to import numerical Python as NP. So we use the alias NP, and we're also going to import matplotlib.pyplot as PLT. Now, I know that's a big mouthful, but don't worry, you will get used to this. So whenever you want to produce a pretty picture, you have to insert those two lines. So x is going to be a vector of values. So we use this function linspace. X will go from -2 up to 2, and we'll take 100 points. Take 100 points between -2 and 2. So we get a nice smooth curve. Y will be given by x squared. Okay, this is what we call a quadratic equation, and this will give us a parabola. Next, we want a plt.plot. So within plt, within matplotlib.pyplot, there is a function called plot, and we're also going to simply plot x against y. To make the picture look pretty, we'll do plt.xlabel. So we'll give the x label as x. Similarly, we can have plt.ylabel, and we'll make that y. We'll put a nice title on our figure, plt.title. And because this is mathematical equation, we're going to use the dollar symbol, and we're going to use something called LaTeX. So we say y is equal to x to the power 2. So this is LaTeX, and if you attend the workshop, I will show you, we will discuss more about LaTeX. So it's how you put mathematical equations into your figures, etc. Next, we're going to save the figure. So we go plt.savefig. So somebody's written a function called savefig. We will save it as parabola.png, but you could do a TIFF or a JPEG or EPS, whatever form you like. And we can even tell Python how many dots per inch we want. So we'll make it 300 dots per inch. When you publish journal papers, the journal will quite often ask you, to do it in certain dots per inch. And then we plt.show to show the figure. I think there are no errors here. Okay, if there was an error, it would be underlined. Let's see if we get our figure. Okay, we get our nice figure, and you can see you get a nice parabola. Also, because we've saved the figure, you'll now see that we now have parabola.png in our folder, and if you want to download that, we can simply download. So we can download our figures. Finally, we might want to change the font size. So we use this plt.rcparams, and then we say font.size. So this is very useful. So we say the font size is let's say equal to 20. Just let's see what that looks like. Okay, so we're going to change the font size. Is that correct? Probably a bit too large, so let's make it 14 instead. So you can just change this until you're happy with the font size. Okay, so there's a nice colorful picture. This is cloud computing. You can see here, this green tick shows we are connected to the hosted runtime. This is cloud computing. You don't need any software on your computer. So I hope you've all enjoyed the summary video, and I hope to see you all again for the full workshop.